Okay, so the first example that I'm going to try to solve step by step is going to be the first system of equations that comes in the PowerPoint that you guys have access to. That's 4x plus y equals 4, and 3x minus y equals 3. So those are two equations. That means that there's a graph, a line associated with each one of those, and we're going to try to find what is this point where those two graphs meet. This is going to be the solution. So we're going to use the substitution method, and this method works when one of those two equations has a variable that's by itself, a variable that does not have any coefficient, any big number associated with it. So we can see that on each of those two equations, we have one variable that's by itself, which happens to be the y. So this is why we're going to use substitution method to try to solve this system, because one of those variables is by itself, and this is where substitution works the best. Okay, so the first step in substitution method is I have to solve for one of those four variables that I have in that system. I have two variables in each equation. I have to solve for one of those variables. So if you see, the easiest variable to solve for is going to be the y in the first equation, because all I have to do is subtract 4x from both sides, and that's going to solve for y on the first equation. So this is the first step. This is the first thing that we're going to do. It's going to be solve for y on the first equation, or in equation 1. So my equation 1 is 4x plus y equals 4. And the only thing that I have to do is subtract 4x from both sides. You can do whatever you want to an equation as long as you do it to both sides. This 4x's in the left, they're going to cancel out. So my new equation, or the equation now, is going to look like 4 minus 4x. Remember that we are not going to combine like terms. Well, we're not going to combine those 4 and negative 4x because they are not like terms. Okay, in order for them to be able to be combined, they have to be like terms. They have to have either both of them x or both of them not have an x, right? Both of them be just numbers by themselves. Okay, so as the first step, we have to solve for one of the variables. Again, if you want to solve for any of the other variables in the system of equations, you're good to go. You can also do that. Okay, that's the first step. The second step is going to be substitute the expression in the other equation. Now, on this equation that I found, or that I came up with, I have this value for y, right, which is 4 minus 4x. This means that this value for y, if I want it to be the exact same point, or the exact same y value for both graphs, it means that I have to take this expression and substitute it in the y of the other equation. So in this case, I'm going to take the expression, and this is going to get substituted into the y of the second equation. So this is the substitution method. You have to solve for one equation, or one variable in one equation, and then this result that you get, right, the expression that you just get, you have to substitute it in the variable of the other equation, and then you're going to be left with an equation with just one term, or one variable in there, which is either x's or y's, and this should be fairly simple to solve. Okay, so let's go ahead and do the substitution. So my equation 2, it looks like 3x minus y equals 3. And what I'm going to do is I'm going to replace the y, just the y, for a parenthesis, where I'm going to substitute the expression that I found in the previous step. So expression that I found in the previous step, that's 4 minus 4x. At this point, can you see that the only thing that I have in here is x's? So it means that I can solve this equation through the conventional methods, right? So let's go ahead and get rid of that parenthesis, first distributing the negative sign that's in front of it as if it was a -1. So this negative sign in front of the parenthesis means that I'm going to change the sign of everything inside the parenthesis. So the first number is a +4. That means it's going to become a -4. And the second number is a -4x, so it means it's going to become +4x. That's the rule for a negative sign in front of a parenthesis, or if you distribute the negative sign. Okay. The next thing that I'm going to do is going to be combine like terms. So whatever terms have an x or whatever terms don't have an x on the same side of the equation, they have to be combined. So I'm going to combine 3x plus 4x, and 3x plus 4x is going to be 7x. Everything else remains the same. Scroll up a little bit. Now at this point, I have to send all the terms that have a variable to one side and all the terms that don't have a variable to the other side, or the constants or the numbers by themselves. So I have a -4 right next to the 7x. This has to be sent to the right side of the equation. So if it's subtracting, the opposite operation of a subtraction, it's an addition. So I have to add 4 to both sides. 4's on the left cancel out. All I have left in the left side is going to be 7x equals, and then I can add those two like terms, 3 plus 4, that's going to be 7. At this point, I don't have any more addition subtractions, so I can start dividing, multiplying and dividing, depending what the operation I have. Remember that you're doing the opposite operation of what you want to get rid of. In this case, I have a multiplying 7. So how do I get rid of a multiplying 7? If you divide by 7. But if you divide by 7 the left side, you have to divide by 7 the right side. 7's cancel out. X equals 7 divided by 7, which is equal to 1. So this is the first value, the first component of the solution of this system of equations. I have to find the next component, right? This is the domain. I have to find the range. I have to find the y value. So the third step, there's a third step to this. I'm going to call this back substitute. So you're going to take the value that you got and you're going to back substitute it in, we're just going to say in any equation. So whichever of those equations it's easier to substitute in, that's where you're going to substitute this x equals 1. So you replace all the x's in that equation for a value of 1. So if I go back to my system of equations to the very beginning, I have to choose in which of these two equations I'm going to substitute x. Again, whichever equation you choose is not going to make a difference. It's going to be perfectly fine. We're just trying to choose which is the best equation to substitute in, so it's easier to solve for y. And I can see I'm going to choose the top one just because it doesn't have any negative signs, and it's easier for us not to deal with negative signs. So I'm going to take the first equation, and that's where I'm going to substitute the value for x that we just found. Okay, so for x plus y equals 4, that's going to be my equation, equation 1. For x plus y equals 4, and this is where I'm going to substitute the value for x. That's x equals 1, so I'm going to replace the value for x. So I'm going to change that x for a parenthesis, and inside the parenthesis I'm going to substitute the value that I just found, which is a 1. And you have to try to solve this equation. So let's get rid of that parenthesis. That's going to be 4. 4 times 1 is 4, plus y equals 4. So remember that the goal is to send all the letters to one side and all the numbers to the other side. So I'm going to get rid of the first 4. I'm going to try to send this to the right side of the equation. Since this is a positive 4, I'm going to subtract 4. If I subtract 4 from the left side, I have to subtract 4 from the right side. So these two numbers cancel out. The only thing that I have left on the left side is y equals, and then I can do 4 minus 4, which is going to be 0. So this is my solution for the system of equations. It has an x component over here on the top, and it also has a y component. It's a coordinate. Remember that this is the coordinate where those two graphs combine, right, or meet, collide. So we can report this as a number, which is going to be the domain 1, 0. Okay, this is the way to report it. We can also say x equals 1, y equals 0. That's also a coordinate, which is the answer for the system of equations. Now, there's a fourth step that we should always do, which is the check. So we have to substitute these two values that we just found into my both equations that belong to the system. If this value satisfy the equation, well, it satisfies both equations, then these are the correct results for the system of equations. So my original equations are for x plus y equals 4, and I'm going to scroll up, 3x minus y equals 3. So I have to substitute these values into those two equations to make sure that those are correct. So I'm going to plug those values in, right? X equals 1 and y equals 0. I'm going to substitute those values into my first equation. Plug them into the first equation. That's 4x plus y equals 4. So x is 1 and y is 0. So if I do PEMDAS to the left side of the equation, that's 4 times 1 is 4 plus 0 equals 4. So that those two values for x and y, they satisfy the first equation. Right? 4 equals 4. Those two numbers have to be equal to each other. Now if I substitute those into the second equation, let's see what I get. So the second equation looks like 3 times x minus y equals 3. So now the value for 1, that's an x, that goes into x's. And the value for y, that's a 0, goes in the y. Right? I am replacing these values over here on the equation. Okay, if you do PEMDAS, that's going to be 3 minus 0 equals 3, and 3 equals 3. As long as these two numbers are the same, that means that x equals 1 and y equals 0 is the solution for this system.